All right, we are starting a new unit, trigonometry. The nice thing about this unit is almost everything in it is going to be review stuff you've seen before. Um, but there will be a few new things here or there, in particular, depending on the last math course you took. But a lot of it's review. For some of you, there might only be one or two little new things or things that are a little bit different, but it's a good opportunity to do really well on. Maybe there were things that you didn't get last time you saw it, and this time you'll get them. We're going to move a little bit faster, so keep that in mind. There is going to be an expectation that we remember some of what we did from previously from last year, and so if there is anything that goes too fast for you, you got to make sure that you ask. You really have to understand that in particular what we're doing today is stuff you've definitely seen, but if it's been a year, it might be a little bit rusty. So if there's stuff you don't understand, rewatch the video or ask, and make sure that you figure it out, because you don't want to miss some steps early on that could cause problems later. Um, Now, so this is trigonometry, and like I said, it's stuff you've seen before. However, we're actually doing 2 units on trigonometry, so our next unit is also on trigonometry, and that one is brand new. It's almost all stuff you haven't seen. So keep that in mind, that we're getting a unit of a lot of stuff that you've seen, but then a unit of a lot of stuff that's brand new. So if you want to balance it out, make sure you're still working hard and doing the practice during this unit. And then if you find the next unit a little bit harder because it's new, then it will help balance it out a little bit. All right, let's get started. Um, Today, or the first few days of this unit, and today is everything's about right triangles, and hopefully you remember from the last time you did trigonometry that there's a real difference between whether we're looking at a right triangle or we are looking at a non-right triangle. Right triangle has a 90-degree angle in it, a non-right triangle does not, and we use totally different formulas to solve depending on whether we are looking at a right triangle or not. So the first few days are only dealing with right triangles. Again, it's review. And so we want to nail this before we move on to the non-right triangle stuff, which can be a little bit trickier. And the other thing that we're doing today is we're like I said, we're going pretty fast here. So we are going to look at how to do different solving individually, but then we're going to look at what it means to, quote, solve a right triangle. So this is not a universal math definition, but often what it means in high school math, it has a particular meaning. So that's the big thing that you really want to get out of today. Hopefully that you understand how to actually solve a right triangle, that word in quotes, what we mean by that. But we're going to do a couple of other examples first. So hopefully you remember this. If you don't, after you see this, you will. The word that we use to remember the formulas or the ratios when we're doing right triangle trigonometry. So who knows what that word is? Think about it for a second. See if it comes to your mind. You got to know what it is, and you got to know how to spell it. So the word is SOHCAHTOA. Okay? SOHCAHTOA. And you have to know how to spell it because the letters of each of those 3 parts of the word tell us what the formulas are for sine, cosine, and tangent. So this one is sine of an angle theta is O, means opposite, over hypotenuse. Ka means cosine of an angle theta is equal to adjacent over hypotenuse. And TOA stands for tan or tangent of an angle theta is equal to opposite over adjacent. Now this is the only time that I am going to write out those words in full. We do shorten them to just 3 letters each if we're going to write them out. Okay. And the other thing that we want to know here that's really important to think about, there's little details in trigonometry. Trigonometry can be very different from other kinds of math. And there's little details that you really need to know, and you should be sort of actively thinking about them. So explicitly reminding yourself of these little details while you're working, because if you forget them, they can cause big problems. And they're not intuitive. They're not things that you could just figure out yourself. So you have to kind of know them and remember them. And the one that I'm talking about here is this variable, which is a Greek letter, instead of using English letters like ABC. Sometimes in math we use letters from other languages, and often in trigonometry we're using Greek letters for whatever reason. And so this is the Greek letter theta, and theta is an angle in the triangle. Okay, so you're always doing sine of an angle, cosine of an angle, tangent of an angle. You can't do sine of a side length. That's not how it works. Okay, and SOHCAHTOA is a quick way to remind us what those three ratios or formula are, and to make sure that we get them in the right order, that it's opposite over hypotenuse and not the other way around. And that is what we do when we're doing any kind of right triangle trigonometry. Okay, so we're going to look at a couple of examples here. First one is solving for a side length. The other thing that I like to do when we're doing right triangle trigonometry is I like to point out that there's really only three kinds of questions that you can get. And I do think that we're going to do one of each. And so if you're doing any of the work over the next few days and you are somewhat unsure of how to solve once you've got it set up, because we're going to talk about the different steps of solving these problems. And if you're stuck, if you've got it set up, but then you're not sure how to solve, it's always one of these three cases that we're about to look at. And so you can look back at this lesson as a model and say, oh, it's this case, and this is how I do it. And look back as often as you need to until you can start to do it independently. So the first thing that I want to do is step one. And if you really want to, I will actually write out the steps, but then I'm going to erase them. I don't know that I'll have room to leave them in the lesson here. We'll see if I have room, I'll leave them. So step one, okay, is label the sides. So this is what I always start with. You don't have to do it in the order that I do it, but I mean, why not? It's good to have a habit of how you do it. I always start with the hypotenuse, and for the hypotenuse, you start at the right angle. So this is obviously the right angle. Again, I know we all know this, but I'm gonna just go over it again just to make sure and remind everyone. So the right angle has a square in it. That's how we know it's a right angle. That means it's 90 degrees. I start at the right angle and I draw a line to the side length that's across from it. And that one is the hypotenuse. Okay. And then in all cases, I'm either given an angle or I'm solving for an angle. Okay, it's going to be one or the other for right triangle trigonometry. So in this case, I am given the angle 34. So after I do the hypotenuse, I go to the angle that I'm given or the angle that I'm looking for, and I go across from it. Okay, and that one is called opposite. And hopefully, I mean, most people know the hypotenuse because you've just done it a lot, and you know what the word opposite means. So it's opposite from the angle that we are talking about, okay? And then the final one is adjacent. So that's all three sides labeled. You don't have to do this. It's not necessarily worth marks, but it's a good thing to do, especially early on until you get into the swing of it. The other thing that if you make a mistake doing this kind of stuff, again, I'm going to give you little tips along the way that can help you avoid these kinds of mistakes. So if you have to, this is a good thing to do. I like to point out that you can actually circle the label with the thing that it's beside, whether it's a side length or whether it is a variable, circle it. And that will force me to make sure that I know that this question involves adjacent and hypotenuse, right? Those are the two things that I'm going to use for this question. And if I come up here and I look at which of these has adjacent and hypotenuse in it, and it is cosine. So step 2 is determine the ratio to use. Okay, and in this case it's cosine. I wouldn't normally write this down. I'm just doing this for the lesson. What I would do is I would write out the formula. So cos theta equals, whoops, adjacent, so that's how I shorten it, over hypotenuse. Step 3 is substitute. Okay, and so I've got the angle, it's 34. So theta is always an angle, so it's cos of 34. And I have circled the values that I'm using. So adjacent is 15, because sometimes what people do is they do this. Don't write this down. They always put the variable on top. And that's wrong in this case. But out of habit or out of easiness or something, sometimes people just make that mistake. But look, x is the hypotenuse, which is on the bottom. So that needs to go on the bottom. And adjacent is 15, so that goes on the top. And then the fourth step is the part where we solve. And there's sort of a couple of sub-steps to this, but I'm not going to write them out. I'm not going to break them down. I'm just going to go ahead and solve. Often we need to take a step to rearrange before we can actually find the answer. Okay, and whether you're solving and whether you're doing which of the 3 different types of questions we have that we're about to do one of each, that looks a little bit different. Okay, so that's one part, is we have to do a bit of rearranging. And then the next part is we need to know how to use our calculator. And depending on which type of question it is, again, that looks a little bit different. So there's some stuff that you do have to practice and understand here. And one thing that that we need to keep in mind is the different ways of rearranging will be the same for that type of question every single time. So once you've got it, you've got it. But if you do the wrong one for the wrong type, then obviously you're going to have some mistakes. Okay, so to solve, first I have to rearrange, and then I have to know how to put it into my calculator. Okay, and we'll talk, once we have done one of each, we'll stop for a second before we move on, and we'll compare them. And that will be a big part of getting good at these, is comparing the 3 types, observing what's different about all of them so you can recognize the type that you're looking at. This is the type that I would call variable on the bottom, because the variable is in the fraction and it's on the bottom. And in this case, the variable x and the cos 34 trade places. Okay. What's actually happening, so there's something that's actually happening there, and I'm going to show you, but I don't want you to get to overthink it or worry about it too much, because you can always just go straight to this by remembering that when the x or the variable is on the bottom, it trades places with the trig part, cosine, sine, or tangent, whichever one it is the same thing. Okay. What I'm actually doing is I'm actually cos 34 equals 15 over x. I'm actually multiplying both sides by x. So that's x times cos 34, and the x cancel each other. And so when they cancel each other, I end up with just 15 on that side. So I end up with x times cos 34 equals 15. And then I divide both sides by cos 34. And again on this side, those divide just like if I was dividing by 2 and they divided out. And I'm left with x equals 15 over cos 34. Okay, so that's what's actually happening there. But I don't want you to think it's magic or that there's no reason behind it or it's just some trick. It's not a trick. It's a couple of steps of algebra, but the easiest way to do it and the shortcut is to just remember that the variable on the bottom trades places with the thing on the other side, the cosine, sine, or tangent. Okay. Now, the next part that we have to do is how do we put this into our calculator? Again, part of the tricky part of this is that people have different kinds of calculators, and depending on the kind of calculator you have, you're going to do this question in a little bit of a different way. So I'm going to try to show you both as best as I can on the computer. This one will be good for if you have one of these kinds of calculators. That's a two-line calculator. We can plug lots of stuff in. Whether you have a Casio or not, it should basically look like this. Two ways you can do it. I can do 15 divided by, oops, I got to make sure I'm in the right mode. Everybody's calculator is different. You have to be in degrees. So I'll try to show you. There is number 3 here is DEG, that stands for degrees. Number 4 is RAD, that stands for radians. And number 5 is GRA, that stands for gradians. And we never really use 5 in high school. 4, which is radians, gets used in other courses. But for us, everything will be in degrees, so we always want it on number 3. On your calculator, you will probably notice, like you can even see right here, that there's a DRG at the top of my screen. This online calculator doesn't show the top section exactly the way a real calculator does, but yours will only have the D, the R, or the G. So if you see the R or the G, or some other calculators, it says RAD or GRA or DEG, it says all 3 letters. If you see one of those, you have to fix it. You have to get it into degree mode, and every calculator is different. Try to look up instructions if you can, or ask me if you can. I can try to help you. Look up the instructions for how to get it in degrees. The nice thing is usually if you can just reset the calculator, degrees is default. So I'm going to push 3. So I pushed, here, let me try this again. I pushed shift and then this button for the mode and setup to get to this screen. And then I push 3. And now I know that I'm in degrees. Okay. And I can check that by going cos of 60. And that should give me a half or 0.5, depending on whether it's doing fractions or decimals. So you can check if it's in degrees by doing cos of 60, or if you see the D up at the top or the DEG at the top, you know that you're in degrees. Okay, now I am going to do 15 divided by cos 34. And it looks just like this step. 15 divided by cos 34 looks a lot like that on my calculator. I'm going to hit equals, and this is going to round to 1 decimal place. That's our default for side lengths. So 18.09 rounds to 18.1. And we're working in meters, so I'm going to say meters. The other way you could do this is as a fraction, so it literally looks like it does on the page, but you'll notice if I hit equals right now, I'm going to get an error. And the reason why, and I believe this happens on your physical calculator as well, sometimes this computer calculator acts a little bit differently from yours, but I think in that case you get an error. You need that closing bracket in this case to get the right answer, but you'll notice that's exactly the same as the last one. And in fact, notice that I didn't need the closing bracket when I did it this way, 15 divided by cos 34, but when I write it out as a fraction, I do, otherwise it gives an error, and it's just the way the calculator is programmed. Okay, so that is one of the 2 types of solving for a side. Now I've got space down here at the bottom, so I will leave those steps up there. The steps are going to be the same for all the different kinds. So those are the 4 steps for solving these right triangle questions. Okay, so if you want to write those down and try to sort of memorize them or use them as your path way to answer these problems, that's a great idea. So I'm going to do another one, and this one's going to be one of the other sort of types of questions, but I'm going to still start with label the sides. Remember, I always like to start at the right angle and go across from that to get the hypotenuse. Then I go to the angle that I'm either given or looking for and go across from that, and that's opposite. And then the last one's adjacent, which in this case I don't need it because I don't know it and I'm not looking for it, but it is adjacent. I'm going to circle the two that I either know or I'm looking for to make sure that I sub in correctly and that I use the right ratio. This one is hypotenuse and opposite. Again, I look at SOHCAHTOA and I can see that this is hypotenuse and opposite. And so I'm using sine. So step 2 is determine which ratio we're using. In this case, we are using sine. People call it sin, but it's actually sine because it's short for S-I-N-E, but either way, it doesn't matter. Sine theta equals opposite, so OPP over hypotenuse HYP. Step 3 is substitute. The order that you substitute doesn't matter, but you got to put the right things in the right places. Theta is the angle, always. So it's sine of 18 equals opposite, which is y in this case, over hypotenuse, which is 20. Okay, now I'm going to stop here and we will compare all three, but I'm going to compare these two specifically because these are the two types of questions that we can get solving for a side. And people think that it's because one's cosine and one's sine. That's not it at all. Whether it's sine or cosine makes no difference. That's just the button you're going to push on the calculator. You're going to either push sine, cosine, or tangent. Okay, but what it really is in this case, I have x on the bottom. And in this case, I have my variable, happens to be y, on top. Okay, that's what makes one question work out one way and the other question work out the other way. So in this case, I'm going to multiply both sides by 20, and the 20 moves over here. And take a look at the difference between these two. In this case up here, I divided. In this case here, I multiply. So if I have a variable on the bottom, like our first example, I end up dividing. If my variable is on top, I end up multiplying. And you don't get to choose. That's based on how the question is set up. This one I'm looking for opposite, so that's a variable on top. This one I'm looking for hypotenuse, so that happened to be variable on the bottom. So that's how it's going to work out. You don't get to decide, but it's going to work out one way or the other, and you have to know how to do both types and recognize that they're different. And it's the rearranging part that's hard, and it's usually this one that people mess up, and they end up multiplying when they're supposed to be dividing, right? So people would have done this. They would have said x equals 15 cos 34, but that's wrong. It should be 15 divided by cos 34. Okay, so let's go ahead and solve this one. Now this one is multiplying, so I'm just going to go 20 sine 18 equals, and I get y is approximately, again, rounding to one decimal place, 6.2. 6.18 means the one rounds up to a 2, and this one was centimeters. Okay. So we'll come back to these when we've done the last one as well, but starting to notice how we can identify the different types. Those are the only two types of solving for a side. When you're doing right triangles, you're solving for a side and the variable ends up on the bottom, or you're solving for a side and the variable ends up on top. Those are the only two types. Now, I forgot to talk about the other calculator, so I'm going to go back and do both of these before we move on to the next question and show you how to do it. And remember, for the first one, I did it like this, 15 divided by cos 34. So I kind of type it out the way that it looks. And in fact, like I said, you could even use the fraction button and do it that way, and it's even easier. But I can type it out like this, and I type it out in the order 15 divided by cos 34. That gives me the answer. What if I'm using a calculator, and this is, whoops, the best that I could do so far for a more simple kind of calculator, and lots of people are going to have one like this. And this one, you're going to type things in sort of backwards compared to the other one. So I am going to type in the 15 first and divided by, but I'm going to put the angle in next. So 34, and then I'm going to hit cos, and on this one I do it like that, but yours will probably have a button, and it's going to come up with some kind of number. I'm just going to ignore that. That's not the answer. Okay, I have to hit equals to get my answer. And take a look at that. It's 18.09, just like this one was. The exact same, 18.09326923, and so on. Okay, so that is how you do it on that calculator. You type in 15 divided by 34, hit cos, then hit equals, and you get your answer. How would I do the other one? 20 times sine of 18. So I can do 20 times, put the angle in first, then hit sine, then hit equals. And there's your 6.18 or 6.2. Or for this one, I could do it all the way backwards and go 18 sine times 20 equals going to give me the same thing. Okay, so it really is up to you to learn your calculator. And once you do, you'll get it. So even if your calculator is different from mine and you might at first think it's hard, once you figure out how to do it and you practice it a bunch of times, it'll be really easy for you and you won't have any problems. Okay, but you do have to make sure that you know how to punch it into your calculator again. Ask if you're not sure and we'll see if we can figure it out and work it out. But pretty much every calculator in the world is going to be like one of those two that I showed you. This is the last of the three types of questions that you might come across, and it is when you are solving for an angle. Okay, so the steps are going to be the same, but the way I punch it into my calculator is going to be different. First step is label the sides, and across from the right angle is hypotenuse. In this case, I'm looking for an angle, but I'm still going to go to that one, and across from the angle I'm looking for, that's still the opposite. And the last one is adjacent. And I'm going to go ahead and circle them. And I am looking for the one of the ratios that is opposite and adjacent, and in this case it's TOA, which is tangent. So I have picked I've determined the ratio that I'm using, so tangent. And I'm going to write out the formula. Tan theta is opposite over adjacent. And tan theta, because that's the angle, is opposite, which is 4, over adjacent, which is 3. And lots of people could have gotten that backwards, 3 over 4. That's one of the reasons why I circle them, and I look at opposite on top, and there's my opposite. So I'm going to make sure it's 4 over 3. And in this case, I don't have to do any rearranging, okay? But what I have to do is understand how to put this into my calculator. And I'm looking for an angle, so there's something special that we do when we're looking for an angle. And that is I have to hit shift before I hit tan, which gives me the little tan to the -1. It looks kind of like an exponent. It's not, but it looks like that. And it's tan -1. And then I'm going to put in 4 divided by 3, just like that. Hit equals. And I'm going to round this to the nearest degree. So the nearest whole number, and it's 53 degrees. Okay, and so you notice that I didn't have to rearrange, but I had to remember to hit shift before hitting tan to solve this one. If I was in the wrong mode, if I was in radians, for example, and I tried to calculate this, look how different it is. It gives me this decimal. So it's way off, and that might tell you that you've done something wrong, because we don't usually get answers that are decimals like this when I am solving for an angle. So that's probably an indication that you're in the wrong mode. Go back to degrees and you're going to get a proper angle. And the angle is going to hopefully look something like the actual angle in the picture, but that's not always the case. What if I'm using the other one? Well, in this case, I'm going to do 4 divided by 3, hit equals. And in fact, I haven't even tried it on this calculator. Let's see, trigonometry. Then I'm going to hit second function or shift like before. And you'll notice on this one, it changes the look of the button. And I've got that -1 there again. And if I hit that, it gives me the answer directly. So for the other kinds of calculators, you do the 4 divided by 3 first. Then you hit shift or second function. and then you hit tan. Okay? So must use the shift or second function button when solving for an angle. Now, like I said, I'm going to go back and I'm going to look at all three of these types. Solving for a side length, x on the bottom. Solving for a side length, x or y variable on top. Solving for an angle. Those are your three types. Every question that's a right triangle will be one of those three. Okay? And if you've set it up correctly, you're going to follow one of those three steps. You're either going to end up dividing by trading places. You're going to end up multiplying by just moving the number on the bottom over and multiplying on the other side, like that, right? Or you're going to use shift and then divide by the other thing to find the angle. Those are the only three things that you can do, okay? And so once you've nailed all three of those, I mean, there are some other kinds of questions. The way you solve is the same, but the setup might be different, or there might be more steps to them. But the setup and the solving is, or the solving is, it's the same no matter what. So those are the three you have to get for right angled triangles. I hope that that was a good enough review. You've seen that before. If you have to go back and rewatch that, of course, go and do that. Otherwise, we're going to move on to one more thing today, and that is this special definition in high school math of what it means to solve a triangle. So any question that says solve the following triangle, this is what we mean in this course. We mean find all the missing information about the triangle. Every triangle has three sides and three angles, okay? And to solve, now this is true for right triangles and non-right triangles. We know triangles have three sides. They always have three angles. So that's 6 things total. 3 of those things will always be given. It's up to you to find the other 3. And every part of a question like this will still be one of these 3, basically, but you're going to have to do it more than once for one question. That's the difference. And there are some other little tricks that will just help speed things up, make things a little bit faster, and we'll talk about them as we go. And one of the hard things about solving triangles is that there's some choice. There's often some choice of exactly how you're going to do it. So there's no one step-by-step way of doing every question, and some people find that hard. That's even more so true for non-right triangles. But for right triangles as well, sometimes you have some choice, and that makes it hard for some people. Okay, but I'll try to walk you through some of the different options. You're going to pick your favorite, and hopefully, you'll kind of be able to do it more or less the same way every single time. Now, one thing you don't have a choice about for these questions generally is how you start. So there's one thing you're gonna have to do first. Actually, that's not true. For this question, we do have some options about how we can start. There's different things that we could try to find first if we wanted to, and that's going to change the question and how we proceed further. There are other questions that are going to come up later where it is totally true that there's only one thing you can find first, and you have to start with that. But after that, you're probably going to have some choice. Okay. But then there's some other kinds of questions, right triangles, where you actually do have some choice in how you proceed and how you solve. Okay. I'm going to notice that so this is right triangle. Everything we're doing right now is a right triangle, but down the road it won't be. So it's good to notice that this is a right triangle, and that counts as one of the pieces of information because I've got 1, 2, 3 sides, and I've got 1, 2, 3 angles. So the right angle is one of those angles. And in right triangles, we're always going to be given the right angle, because we need to know that it's a right triangle and which one is the right angle. So that's always going to be one of the pieces of information for right triangles. Okay. The other thing I like to do for these before I move on is I like to write out a little summary. And this is a great way to show your work, to communicate your answer, for me to follow if I'm marking your work, but also for you to be able to tell if you're all the way done or what you have left to do if you're not done. So this is what I'm going to do. I'm going to write out, I'm just going to look for the right space to do it. I guess I'll do it right here. I'm going to write out all of the angles. So L, M, N, and then I'm going to write them out like this, L, M, N. So in these questions, we didn't have this, but there's a standard in mathematics when we're working with shapes or triangles specifically, because that's what we tend to see is in trigonometry and high school math, is that if I have a capital N here, then it's little n across from the capital N by definition. So I would never call this side X. I would always call it little n because it's opposite from the N. Okay, it's the hypotenuse of this triangle, but it's across from capital N, which means across from capital M is little m, and across from capital L is little l. Okay, so I'm going to write those out, and now I'm going to fill them in with the information that I know. And I'm going to use a different color. Obviously, you don't have to do this. But capital N is 90 degrees. Little n is 17.1 centimeters. And little m is 13.0 centimeters. So I'm going to fill those ones in a different color because I know those are the ones that I started with. Now, in this case, I can find angle L, angle M, or side length L. I could find any of them. I'm going to go ahead and find an angle first. And I like to do these little titles because it makes my work really easy to read and clear. And it also lets me look back at my own work. Like it's clear for somebody else to look at it. You know, if I'm marking your work, this helps me. But it's also good for me looking back at my work so I can figure out what I was thinking, what I was doing at that time. So I am going to find little l, or sorry, capital L, big L. And to do that, I'm going to label the triangle. So across from N is my hypotenuse. And across from L would be the opposite, which would make this adjacent. Okay? And so hypotenuse and adjacent is cosine. So for this one, cos theta is adjacent over hypotenuse. For this question, I'm using cosine. Now I'm going to sub in, and instead of theta, because it's not actually theta, I'm going to say cos of capital L. If you left it as theta, I'm not going to mark it wrong, but this is a good habit to get into. Adjacent is the 13.0, and hypotenuse is the 17.1. Okay, and I'm going to punch this into my calculator. So remember, I have to do shift cos. If your calculator doesn't open a bracket, you need that bracket. 13.0 divided by 17.1. Hit equals, and L is approximately, and I only need to do one decimal place, but I'm going to keep a few extras. I'm going to talk about that in a few moments why. So I'm going to keep 4 decimal places for that. But I'm going to go ahead and fill it in. Oh, this is an angle, so it's just rounded to the nearest degree, which is approximately 43 degrees. Okay? But I'm going to keep 4 decimal places here for a reason that, like I said, I'm going to talk about. So that one's done. Okay, now I've got L finished. Now, before I move on, I'm going to talk about a few things, and I'm going to keep talking about this every time it comes up. So if it goes a little fast now, if you don't quite get it, hopefully it'll come back around and you'll have a chance to think about it again. But it is something that is important eventually to kind of think about. Like I said before, I have some options here. If I want to find angle M next, I could use sine And take a look at this. If I change from angle L to angle M, actually I'm going to leave L there for a minute, but imagine I take away L and I'm going to M. Okay, when I did L, I was doing green. Actually, let me pick a different color. Sorry, I'm all over the map here. I did that with the hypotenuse. If I switch to M, well, that's not the adjacent anymore. This is now opposite. This was adjacent to L, but it's opposite of M. Okay, and this is something that people have a hard time with, that if I change the angle I'm talking about, we were talking about L, now I'm changing to talk about M. I have to relabel my triangle. So be careful of that. You never have to relabel the hypotenuse. It's always across from the right angle. That's not going to change. But adjacent and opposite will change. So if I decided, I'm going to get rid of all of this because it's kind of mucking things up. If I decided to use trigonometry for M, don't write this down, just watch for a minute. Okay, it would be sine of M equals opposite, which is 13.0, over hypotenuse, which is 17.1. And take a look at that. That's the same. I'm doing 13.0 divided by 17.1 in both cases. But in this case, I'm doing cosine, and in this case, I'm doing sine. Because for this angle, 13.0 is adjacent. But for this angle, 13.0 is opposite. Okay? So I had to switch them. And that's going to work. It's going to give me the right answer. So I'm going to show you, but again, don't write this down. Shift sine 13.0 divided by 17.1. Okay, so it's going to give me 47.2, which will be 47. However, there is an easier way to do this. That is something you need to understand about switching the angle, means you switch the labels. But there is an easier way that often will work, and you don't have to worry about switching angles. Sometimes you might have to, but in this case we don't. And it's this idea, and you probably already know this, that the three angles in a triangle always add up to what? To 180 degrees. So that means I can do M equals 180 minus 90, because that's one of the angles, minus 43. So I'm using this, right? And I'm going to do that on my calculator now. 180 minus 90 minus 43, and watch, I get 47. And that's what we had rounded there, was 47. Okay, so I get the same thing. And that's a lot easier than using trigonometry again. Okay, last thing. Now we're doing 4L. Once again, I don't want you to write this down. I just want you to watch. I can use trigonometry to solve for this. And that would be fine. Let's say I want to use angle L, because now I know it's 43 degrees. And I'm going to go across from that. And across from L, this would be opposite. And I'm going to use the hypotenuse. Okay. And I'm going to do this off to the side because I'm going to leave it here. Opposite and hypotenuse is sine. So sine theta is opposite over hypotenuse. So sine of 43 equals opposite, which is L, over hypotenuse, which is 17.1. And so that means 17.1 times sine of 43 equals L. Okay, again, don't write this down, just watch. L equals 17.1 sine 43. 11.66, so 11.7. Okay, I'm just going to hold that there for a minute. And I'm going to say there's another way that we can do this. And you remember this from grade 9. And I'm sure you saw it in grade 10 as well. And that's called Pythagorean theorem. Pythagorean theorem relates three side lengths in right triangles. Okay, and so if I have two of the side lengths, I can find the other one. And so Pythagorean theorem looks like this. C squared, which is the hypotenuse, is a squared plus b squared. But in this case, I know the hypotenuse, so it goes in over here. A and b doesn't matter which one's which, so I'll call this L squared plus 13.0 squared. In this case, the 13.0 squared has to move to the other side. So I get 17.1 squared minus 13.0 squared equals L squared. Take the square root of both sides. I hope this is familiar because, again, I know I'm going over this quickly. You don't have to show all those steps. In fact, you can start at that step if you really want, because you can just think of that as a formula. Or you could start at this step or whatever you want. Because I know the hypotenuse and I'm looking for one of the other sides, I'm subtracting. Okay, otherwise I would be adding. But that's what I end up with. And watch what happens when I punch this into my calculator. Let me move this over again. Square root 17.1 squared minus 13.0 squared equals, now I got 11.1. Huh. Now, does that matter? That's fairly different. And my answer to this is, well, it depends on what you're doing. If you're talking millimeters and you're working with wood, a few millimeters won't matter, right? If you're off by a couple of millimeters, wood is very forgiving. You'll still be able to screw it together or smash it together with a hammer, pound things into place, probably not a big deal. If you are building a spaceship of some kind, well, then it matters because your measurements have to be perfect. Otherwise, panels might not fit together properly. And in fact, there was a famous accident that happened years ago, the Challenger crash. And I believe it was because two panels that are on the outside of the rocket ship. I don't know if it was quite on the outside, but it was like the exterior part of the rocket ship. The panels didn't line up properly, and there was a bit of a gap. And so that caused the spaceship to explode in the air because there was kind of almost like a hole in the side because the panels were not created to the proper size. And it wasn't by much. It wasn't like there was a gaping hole. It was a very small amount that it was off by. So it really depends on what you're talking about. If we're talking millimeters, that's not that much. What if these are kilometers? 11.7 kilometers and 11.1 kilometers can be pretty different, right? Those are pretty different lengths. Or even meters. That's half a meter off. If you're building a bridge and you're half a meter off from one side to the other, that might be a problem. So it depends on what you're doing. My rule of thumb for everybody is I like people to realize if their answer might be a little bit off. Okay, if you show your work, then it's fine if you're a little bit off. If you don't show your work and your answer's wrong because of this kind of rounding mistake, that's going to be a problem. I'm going to show you exactly why this happened. This answer is correct. So why was this one wrong? Well, I used 43, but that is the actual answer. Even that answer is rounded. So what if I went back to this step and used a better angle? 17.1 times sine of 42.7381. Well, look at that. I got 11.6. That's not even exact. That's still off by a little bit, but it's a lot closer, isn't it? And if I kept even another decimal place, I would probably get 11.7 exactly. If you remember, this one was 11.66. This one's 11.60. So they're very, very close. So in some courses, we would expect people to be exact, and it wouldn't be okay to say 11.1 or even 11.6 when the correct answer is 11.7. But in this course, I'm not going to be as strict. As long as you show your work, I'm going to be okay with that. The problem is when we use a rounded answer, our next answer is going to be off a little bit. In this case, I did not use a rounded answer because I used two numbers that were given in the question. In this example, I used the rounded 43, which was my answer that I got from a different part of the question. Okay, so that's using a rounded answer, and that's when you have to be careful about your answer being wrong. If you're going to use a rounded answer, keeping 4 decimal places at least is a good idea. Whoops, what happened here? A squared plus b squared. Okay. It is possible to do it this way without even using a rounded answer. It is certainly possible. Boy, I've erased a whole bunch of stuff and I didn't notice. So I'm going to go back and put this back in. Sorry about that. This one is, 17.1. Whoops. Okay, sorry about that. But I'm not going to get into that now because we've already gone over a lot today. So if possible, the best thing you can do is not use rounded answers. For right triangle trigonometry, you don't have to. But that means you might be using Pythagorean Theorem, which we did here, instead of using trigonometry like I did there. But just be aware that if you're using a rounded answer, that can be a tricky thing. So 11.1, I'm going to add that in. 11 point, whoops, I'm going to do it in blue because it's not a given. 11.1 centimeters. And I've got my 43 and my 47. And so this is another reason why I like my little summary here, because when it's all filled in and I've got all 6 things, I can see it and I know I'm done. Okay. Now we've got a couple more examples here to do. I'm going to do them a lot more quickly. I'm going to set up example 2 but not solve it, but there's something important to talk about there. So we are going to set up example 2 and I will solve it and post the answer, the full solution to the classroom with the completed lesson. And I would encourage you to try to finish example 2 and then look at the answer in the classroom. But I'm going to do example B first and just set up the next example, and then that'll be it. So again, I'm going to do this: A equals B equals C equals, and then little a, little b, and little c. So big C is 19 degrees. Big letters are always angles, little letters are always side lengths. Across from C is little c, so this is 30 kilometers. And remember I told you one of the things, the piece of information that you're given will always be the right angle when we're doing right triangle trigonometry. So I'm going to fill that in. Now this one's, to me, easy what you start with, because if I have C and I have B, it's really easy to find A. So I'm going to start with that. Okay, and again it's A equals 180 minus 90 minus 19. 180 minus 90 minus 19, and that's going to give me 71. That's not rounded, that's exact. Okay, and now I can do either little a or little b. I'll do them alphabetically, why not? This is a little bit tricky though as well. So little a, whoops, I kind of messed myself up here. I'm just going to move that out of the way. I know you can't do that. Um, little a is here and little b is here. Okay. Now, I know what this angle is, and I can write it in if I want. It's 71 degrees. And so I can either use angle A or I could use angle C. If I use angle A, hold on. Let's take a look at B first. That's hypotenuse. That's what I always start with, so I'll start with that. If I want to find angle A, or sorry, if I want to use angle A, then little a will be opposite. But if I want to use angle C, little a will be adjacent. So again, this is where it's a little bit tricky. Depending on the angle you use, the sides will change labels. So you've got to pick the angle that you're using and go with it. You can't change it halfway through doing, like solving for little a. So I am going to use the 19 capital C because it's given, and that just allows me, I mean, in case I did make a mistake finding this, but that's pretty easy. I probably didn't, but it's just, it's the one that's given, so I'm just going to use that one and ignore the 71 that I had to calculate for. And that to me is just one little trick to make sure that I pick one and stick with it. So if I'm using 19, this becomes opposite. I already did hypotenuse, and this last one is adjacent. Okay, and I'm looking for that, and I'm given that. So it's opposite and adjacent, which is tangent. So tan of 19, this is what happens. Some people label the triangle for using 19, and then they plug 71 in there for some reason. And that would cause everything to fall apart. So I labeled it for 19, so I have to use 19. Opposite is 30. Adjacent is A. This is variable on the bottom, so it trades places. And I go 30 divided by tan of 19. 87.1. And I'm going to fill that in here, 87.1 approximately. And that is kilometers in this case. Now for B, now I could either use Pythagorean Theorem, because now I have two side lengths and I could find the other one, and maybe I will show that because it'll be a little bit different from the last one. But again, that uses a calculated answer. To use Pythagorean Theorem, I'd have to use this rounded answer, and I want to avoid that. So I'm going to go ahead and use trigonometry again, and I'm going to use the answers that I was given. So instead of solving for A this time, I'm solving for B. So now I'm looking for which one uses opposite and hypotenuse, because I know the opposite and I'm solving for hypotenuse. So that's sine. So sine of my angle 19, that's how I labeled the triangle, is opposite, which is 30, over hypotenuse, which is B. Again, this is variable on the bottom. Whoops, B sine 19, B switches places, equals 30 over sine of 19. So B equals 30 divided by sine of 19. It looks a lot like the last question, doesn't it? And that gives me 92.1, and that's 92.1 kilometers. Okay, and it's 30 divided by sine of 19 or 30 divided by tan of 19, and look how they give me different answers, right? So sine, cosine, and tangent all do something different. That's why they're different formulas, and one of them is opposite and hypotenuse, and the other one is opposite and adjacent, and then cosine's the other one. but you got to use the right one for the right question. I've finished my little summary, so this question is completed. Um, Something that I haven't talked about yet, actually I'm going to wait. Let's just quickly look at Pythagorean theorem if I wanted to do that for this question. So c squared equals a squared plus b squared. C is the hypotenuse. In this case, it's kind of confusing because it's actually side length b. Okay, so if I really wanted to, I could say b squared equals, and my two side lengths are 30 plus the one that I found, which was 87.1 squared. Now this is strange. Why did the b go from here to here? Well, it didn't. Okay, this is a formula that often uses a, b, and c. This is a triangle that was labeled a, b, and c. So this b is not the same as the b in this equation. They don't match up, and that's very confusing for some people, I know, but that's just the way that it is. B equals the square root of 30 squared plus 87.1 squared. And this is why I wanted to do this. Take a look at this. I didn't have to rearrange because I'm looking for the hypotenuse and I know both of the other two sides, compared to this one where I knew the hypotenuse and I was looking for one of the sides. Okay, and I had to rearrange and I ended up subtracting, whereas in this case I end up adding. Let's see how close it is using a rounded answer. Uh, 92.1, take a look at that. This would have been exactly bang on. So this is part of the problem, is it's really hard to predict when it's going to be correct and when it's not. I actually got the same answer. Okay, but you just can't tell. But if you show your work, like I said, you'll always get full marks. Last thing before we move on to example 2 very quickly, I know this has been long, is one of the great things about triangle trigonometry is you can think about your answers to see if they make sense. 19 is a very small angle, and so it makes sense that if this side length is 30, it's a lot smaller than the other two side lengths. And if I just look at this triangle, it looks like it's kind of drawn to scale. I can't just measure to think that I can get the right answer, but it looks reasonable. Like 19 is a small angle. And so these two side lengths are similar in length, not the same, but similar. And 87 and 92 are fairly similar. The last thing is the hypotenuse, we should know this, is always the longest side of a triangle. And sure enough, B was my hypotenuse, and it's longer than the others. If I did something wrong and I got this to be like 81.5, I would know it was wrong because you can't be smaller than one of the other side lengths because it's the hypotenuse. And let me go back. What about this one? 17.1 is the hypotenuse. The other two side lengths were smaller. Let me go all the way back up here. When I found this hypotenuse, it's bigger than the other side length that I was given. And same thing for this one. This length was smaller than the hypotenuse. Okay, so this won't always necessarily catch mistakes, but it is something to think about, that we know the hypotenuse is the longest side. And if you're really good at this stuff and you're visual, you might even be able to think like, wow, it should be a lot smaller. It should be somewhere similar to that length. You might even be able to think about that. But just in general, you want to think, hey, the hypotenuse is longest. For some reason in my question, it's not working out that way. I must have made some little mistake somewhere, and that might help you find your mistake. Okay. Okay. Last thing. Solve a triangle with the following information. Once in a while, we're going to get questions where we're just given some values and we're not given the question drawn. So the first thing you have to do is draw the triangle and label it properly, and then it becomes a question just like those. So how do I draw it? Well, I know I'm drawing a right triangle, so I'm going to start with that. I'm going to kind of look at what the angles are. So 37. In fact, with my ruler, I might be able to draw a 37. So I'm going to go like this, okay, and draw a straight line here. Whoops. And let's see, can I do 37? Yeah, I can. So then I'm going to try to kind of get to right above this. I'm going to go a little bit past it. And I'm going to do this, and I'll go back and erase part of the stuff that I drew that was extra, although I got pretty close. Okay, and use a ruler when you're doing this, please, please, please. There, not bad. Okay, so I have drawn my right triangle. I'm going to label the right angle, and that's X. So I'm going to label it capital X. Capital Y, I made this one 37, so I'll label that capital Y. And then Z is going to be this one. Whoops, once again, I didn't leave myself enough space. One thing about when you're drawing these, we'll talk about this more, is if you're about to draw at a certain size, draw it twice as big. If you're not good at drawing this stuff, trust me, that was a lesson that I learned a long time ago, that you don't want to have triangles like this because you can't label them and you can't talk about them. So it's nice to have a bigger triangle. So you might want to just keep that rule of thumb, draw it bigger than you think it has to be. So across from big Z is little z, which is a side length, which is 48 meters. Y is 37 degrees. X is the right angle. And that is that triangle drawn properly. So that's the part of that I wanted to show you. Now that it's set up this way, it's going to be like the other two questions that we did, where you just go ahead and write out your summary and start solving. But that's how you draw it. And then across from big Y is little y, across from big X is little x. But that's how you can, that's how it's not random how you label these. Now I could have drawn this like this. I'm just going to do this one a little bit more quickly. Okay. I still have the right angle here. And I still have, but this now would be my Y, which is 37. I drew the 37 up here. That's still my X. This is now my Z, and my big Z, and across from that would be 48 meters. So notice how, like, in this case, my 37 was down here. In this case, it's up here. But the 48 is still across from the Z, which is what's important. 48 across from the Z. Okay, so even if you draw it like this, you're going to get the same answer as if you drew it the way that I drew it. Okay, I'm going to stop there, and I'm going to let you try to solve that one on your own. I'll put up the solution in the classroom, but just getting that set up and drawn properly is the point of example 2, so hopefully that's enough to get you started. Okay, again, how you put it in your calculator is super important. You really have to practice that. In fact, I can put up a practice sheet that's just those kinds of questions for you that might be helpful. So optional extra practice, look for that in the classroom, and it's just kind of punching it into your calculator and making sure you get the right answer at the bottom of the page. And that's a big part of it. SOHCAHTOA, making sure you pick the right ratio and that you've subbed in correctly. You've labeled the triangle correctly and subbed in correctly. Those are the key ideas for solving. And then, of course, the other part is when you are, quote, solving a triangle. That means you have to find everything, and it's going to require more than one step of work. Okay, and this is all review, so hopefully you've seen it before. I know it's a lot to do in one day. We're going to do something a little bit different tomorrow, and then we're going to have an extra day to slow down and do some practice and sort of make sure we're all getting it. Okay? Okay, good luck with the practice for that.